Before continuing, please take out this handout so you can follow along with the lesson video. We're continuing on in our study of probability, and this lesson will serve as a wrap-up or a review of all the key concepts we've talked about in probability so far. The following data were collected from a bike shop. Calculate the following probabilities as a fraction, a decimal, and as a percent. So here I have a chart showing all the different kinds of bikes being sold at this bike shop and the number of those bikes sold. So we can see the Ranger had 3 sales, the outdoor bike had 5 sales, the Tourer had no sales, Starburst 2, Mountain 10. A customer buys a bike. Find the experimental probability of buying a Ranger. So notice it says experimental probability. This is experimental probability because we are going to calculate probability based on actual sales. So these count as the trials of the experiment, so to speak. So we're looking at the probability of buying a Ranger. Well, how many times did a Ranger get sold? 3 times. How many total sales were there? Well, 3 plus 5 is 8, plus 2 is 10, plus another 10 is 20. There's 20 sales. 3 of those sales were Ranger. So we would say the probability that the customer buys a Ranger is 3 out of 20. Now the question also says to write it as a fraction, a decimal, and as a percent. So this fraction is already in lowest terms, 3 out of 20. So to turn that into a decimal, we do 3 divided by 20. It ends up being 0.15, and that is 15%. So we've written our probability for the customer buying a Ranger as 3 out of 20, 0.15, and 15%. Now recalculate the experimental probability in part A if the bike store decides to discontinue the Starburst. So they're no longer going to sell the Starburst. Well, here's Starburst. They're going to discontinue it. So now, when we calculate our experimental probability, we do not include Starburst in our calculation. So to find the probability of a Ranger, well, it's still 3 sales, but it's not out of 20 sales anymore. It's only out of these 18 sales. So now the probability is 3 out of 18, which reduces to 1 out of 6 in lowest terms. And that's about 0.17, which is approximately 17%. Now this next example is kind of silly, but I just wanted to give you an opportunity to practice tree diagrams. Bob can ride a donkey to work or walk. Further, he has a pair of jeans, a pair of yoga pants, and a pair of overalls. Lastly, Bob can either wear a shirt or go bare-chested. Draw a tree diagram showing Bob's choices. Okay, so again, this is kind of weird and silly, but bear with me. We have choices for transportation. We have choices for pants. And we have choices for a shirt. So there's 3 different categories of choices. And we can list out those choices for each and all the different combinations. So you should end up with something like this. For each choice of transportation, he has 3 choices for pants. For each choice of transportation and pants, he has 2 choices for either shirt or no shirt. Suppose Bob selects from the choices above at random, and we want to find the theoretical probability that Bob rides his donkey to work and wears a shirt. So we need to find out how many different combinations include riding a donkey and wearing a shirt. Then we want to find the theoretical probability that Bob walks to work. How many of these combinations involve walking to work? And then probability that Bob rides his donkey to work and does not wear his yoga pants. So you need to find out that probability as well. So pause the video, try to find all 3 probabilities, and then see how you do. So the probability that he rides his donkey and wears a shirt is 3 out of 12, which reduces to 1 out of 4. As you can see, riding his donkey is all of these possible outcomes, but wearing a shirt is only this one, and this one. Probability that he walks. Well, walking includes all of these. There are 6 possible outcomes that involve walking. So 6 out of the 12 possible outcomes, that means 1 out of 2 in lowest terms. Probability that he rides his donkey to work, okay, that's all of these. And does not wear his yoga pants, so don't count these ones. So there's 1, 2, 3, 4. 4 out of 12. That's 1/3. So hopefully you could get those. If not, you should ask for some help before you move on. This last example deals with a spinner. A spinner is designed for 5 outcomes: car, bus, walk, taxi, and cycle. Cycle and walk are twice as likely as taxi. Car is 3 times as likely as taxi. Bus is twice as likely as walk. Calculate the measure of the angle for the bus sector. Okay, now you might be thinking, what does this have to do with probability? Well, we're going to use that down here when we are actually finding probabilities. So first off, the measure of the angle for the bus sector. Well, I don't have any angles, so how am I supposed to figure that out? Well, this is a circle. How many degrees are in a full circle? 360 degrees. So that 360 degrees of the full circle is divided up into these 5 sections. Now, if I could figure out how big this section is, then I could figure out how big the other ones are because I have the relationship between all of the different sections. Now, I don't have any numbers, so I'm just going to call taxi the smallest piece. I'm just going to say that that angle is x. Now, if cycle and walk are twice as likely as taxi, well, what's twice x? 2x. So walk and cycle both have an angle of 2x. Car is 3 times as likely as taxi. So 3 times x is 3x. So car has an angle of 3x. And then bus is twice as likely as walk. Well, walk is 2x. So what's twice as likely as that? 2 times 2x, that's 4x. So now that I have all of the angles written in terms of x, and I know that they will add up to 360, I can write an equation, then I can simplify, then I can solve for x. So now I know the angle of the taxi sector, which means I can now find the angle of the bus sector, which is 4 times that. So the angle of the bus sector is 120 degrees. So now I've got my angles figured out. Determine the theoretical probability of landing on the bus sector. Well, this spinner is a total of 360 degrees. The bus sector takes up 120 of those degrees. So the probability of landing on bus is 120 out of 360. And that reduces to 1 out of 3 as a fraction in lowest terms. We want a decimal and a percent. So 1/3 is 0.33 repeated. And that translates to about 33%. What's the probability of not landing on the bus sector? Well, it's just everything else. So if it's 1 out of 3 for bus, 2 out of 3 would be not bus. As a decimal, that's 0.66 repeated, which is about 67%. So of course, this was the idea behind the complement, which we talked about in the last lesson. If it's not one thing, then it's the other. They have to add up to the total number of possible outcomes. 1 and 2 make 3. If you need to review the complement, you can refer back to the last lesson. The next question says, suppose walk is not an option, i.e. you must respin if the spinner lands on walk. Find the theoretical probability of landing on the bus sector in this case. Okay, so let's say I flip the arrow and it spins and it lands on walk. That doesn't count. I have to spin it again. So really, we're just excluding this section from the probabilities. Much like when we talked about the bikes, the probability of buying a Ranger bike in the first example, and then the Starburst was discontinued, we just didn't count it anymore as part of our calculation. We're going to do the same thing here with walk. So x is 30, walk is 2x, so 2 times 30, that's 60 degrees. So we're going to, instead of saying that our fraction is out of 360, we have to take out the 60 degrees from walk. So really our fraction is now going to be out of 300. So I just moved this down so we could have more space, but it's going to be set up very similar to this. So we're looking for the probability of bus. It's equal to, well, 120 on the top because that's the angle that the bus sector makes. But it's no longer out of 360 degrees because we have to subtract the 60 degrees from the walk sector. So really our fraction is 120 out of 300. That reduces to a fraction of 2/5 in lowest terms, which is 0.4 or 40%. So hopefully this all served as a good review of probability calculations that we've done so far. If you have any questions, please let me know and I'll do my best to help. Otherwise, you can move on to the practice questions.